Advent of Code day 10. Day 10. Just waiting for people to hop on the stream. Move this over here. What's up? What's up? Time to go. Gonna be a couple minutes before they drop, but I took an L on day 8 and day 9, so I really need to come back on day 10. But I'm hoping that it was just a bad day and an off day because I tried to do 2 questions at once. I actually solved part 1, but it was on a different account. Couldn't get to part 2. There was a small bug there. And day 8, I just got stuck. I sort of knew what the answer is, but it was a little bit hard to implement it. So, I mean, we move on to another day, and it's day 10, and we're about 14 minutes away from that. I got kicked out of my Replit because I just used up all of my... Is this like LeetCode? Yeah, it's basically like LeetCode, honestly. It's pretty much here, I'll show you like the very first question. So, let's see. Yeah, it's essentially like LeetCode. You pretty much get this puzzle, you get this prompt, and it pretty much tells a story, and every single day there's 2 parts to the question. Once you solve one part, you get the answer to the next part. And yeah, you're pretty much given this like prompt, and it tells you like what you kind of need to do, and then it gives you like some massive input somewhere. Where is this? Where's this input? It gives you like this puzzle input, and you take the puzzle input, you run it, you run your code on that input, and then if you get the puzzle answer right, you submit it, and then it will give you a star. After you get the star, the faster you get the star, the better ranking you can get. So these are my stats, or let's see, leaderboard. So my personal times, I was doing pretty good. In day 7, I did really good. Day 6, day 7 I did really good, and then suddenly day 8 I just flopped, and day 9 I just flopped. So hopefully I can do well again on day 10, and I'm gonna like circle back to day 8 and 9 and actually get those solved. But essentially it's like LeetCode. You should try it out, E. I'll send you the link. It's pretty fun. It's actually really good. I enjoy it. We're day 10. I'm going to be using the classic Excalidraw again to talk about my solution. And then from here, what else are we going to do? Day 1, part 2, print. Let me just check. I'm just going to do one quick check that my audio is good. Switch account, get on my burner. Let's see. You draw, yeah, I draw with a mouse on Excalidraw. Do you use Excalidraw? Testing. One sec. Cool. Looks like my stream is working properly. Yeah, I use Excalidraw a lot, so I'll be diagramming a lot of like my solutions. I usually diagram it before I write the code, just so you kind of know what I'm going to be writing. Yeah, I have to like really drop the sensitivity, honestly. If you want to write a binary tree, like that. In literally all of my questions. Oh, John Peralta CFA is joining in. You coming through?
Is this like who's this guy?
New guy. So we have a new YouTube studio. If you look at all my content, I draw things out using Excalidraw. So it's pretty popular in the industry using Excalidraw. Something like that. Just waiting for Advent of Code to drop in 10 minutes. But yeah, I like using Excalidraw for drawing stuff. for whiteboarding. You just get used to it, honestly. I tried to buy a mic or like an iPad that I could diagram on, but I just got the one that I got didn't work well, so I just said, let me just get used to Excalidraw. But now I'm kind of used to it. I don't even want to like look at the last questions that I didn't even do yesterday because those were just tough. Let's see. How did people perform yesterday? This guy's good.
Who's that guy?
A junior majoring in computer science with a minor in... This is the top guy. He has the best rank.
Dang.
He's young. He goes to University of Colorado? How's he so good?
Do you think he uses GPT? Like
Yo.
he has like an auto web scrape into GPT?
I bet you could. I want to try that out, actually. I want to build a bot that solves like 2023 or something. Just for fun.
Like you could scrape that with Traffilatura,
Yeah.
feed it into the AI. Why is that not a good strategy though?
For what?
just
I wonder how
create
you
a
did
bot
this.
that directly feeds.
Are these
it in.
pictures? Yeah. Get you a leak code question to do.
Me?
Yeah, later.
What the?
Let's look for some easy ones. Problem. Look at blind 75. My brother's gonna do a leak code question.
Damn, a
In
lead code
some of the
easy or
big-
hard?
Leak code easy.
I only know arrays.
You only know arrays. Let's see. What is this? Is a medium. Okay. Let's look at arrays questions. Tags. Array. Sort difficulty.
Did I solve these? No.
No, this
way.
is my account.
I was like, no way. Oh, nice. High percentage.
Okay. That's a good one.
What? Get it. 495.
Oh shoot.
49. Output
Okay,
9.
my brother's gonna look at this for a second. I'm just gonna grab water. Just wait.
Oh my.
I was gonna say to use that question. Thought it might.
Which question?
Oh, he's gonna suggest that.
Which question?
They're gonna suggest that's it. I was gonna say to use that question. Thought it might be too easy. But my brother just started doing leak code, so we're just trying to warm him up.
I literally did.
Like, when
three
did-
code
like, yeah,
questions
go-
in my
go-
life, man. But yeah, I started coding like a month ago, and I started doing lead code like 2-3 days ago. But yeah, you can. I don't know, man. What is this? Given two integer arrays, nums1 and nums2, return an array of their intersection. Each element in the result must be unique, and you may return the result in any order. So what does that mean exactly? 4, 9. Okay, so if this number is in this array, it's okay. LMAO, I was gonna say to use that question, thought it might be too easy. Man. Let me see. I don't even know what I'm doing here. Dad, 7 minutes till ad.
What?
I don't even know what I'm doing here. 2. Nums1 set. Make it a set.
Why?
Because all I need to know is that they're the same. W.
W's in the chat.
Oh man, what does that mean?
Let me just.
It's bad.
Nah, W's like W. L is L.
How do I know he's not being sarcastic though?
I don't know.
What?
You figure it out.
What? But then if I do this, I'm definitely doing like n complexity, right? 2n complexity, because I'm making twos. Like I'm pretty much like slightly doubling the list of both. Could I use a hash map for this? No, I don't even know how to build a hash map, bro.
So what's your strategy though? What are you thinking? Just like say it out
I'm
loud.
thinking like make this into a set, and then make this into a set, and then see if this is in this, or this is like. Do I iterate on both? Like for every number in num, check if it's in nums 2. Does that make sense? Because then if I make them both a set, I don't have to like iterate so many times, is what I'm thinking.
Okay. Yeah, print it out. Debug, like that works. Like what you did there.
What? Nums1 not defined. Nums1 set. What? Set nums1.
Look at the variable.
Did I actually make a set? Perfect. It did make a set.
Did it? Or did
It did.
Yeah.
Right here, right? It's DD out. What does that even mean?
What? Standard out? It just,
Okay.
It just means it just got outputted into the.
Set nums2.
Hey, you're doing good, man.
Okay.
You already said W's in the chat.
W's in the chat.
Happy Monday, everyone. Actually,
for
crazy. We're doing this on a Monday. It feels like a Friday. or
element
something.
in nums1 set. If element in nums2 set. I'll probably just initialize this and then make this a set as well.
Well, I said it wants you to return a. It wants you to return a array.
Okay, I could do that. Output array. I'm not that creative with these yet. Output array equals this. So for element in nums1 set, if element in nums2 set, append, but what? Okay, if element in nums2 set, output array. I'll just put another one in here so I'm not double counting stuff. And
Why would you be double counting it?
Because like
Nums
maybe
one set is already unique, isn't it?
nums1 set is already unique, but I could put because I'm gonna iterate through the nums1 set to check if it's in nums2, and then I'm gonna also iterate through the nums2 set to check if it's in nums1. And then
You need to do both of those?
do I?
Oh, think about it. Like if
Dang.
you already compared nums 1 to nums 2, will you ever find something in nums 2 that's not in nums 1?
No, you wouldn't.
Why not?
Because like you're just checking the intersection of each. Like for example, if 2 is not in here, you don't want to add it to the array anyways. If 5 is not in here and you don't want, and it's that means it's not in here, you don't want to add it to the array anyways.
Yeah.
That makes sense.
Okay. Finish it in 2 minutes.
I should do the longer one too though. No. The shorter one's better. For element in nums1 set, if element is in num2 set, and not in the output array already.
Why would it be in the output array?
Oh yeah, because it's no, it wouldn't be because I already made it a set. Element in nums2 set. Huh?
No, it's good. You know why.
Dot append element.
Dude.
What?
You're good, man.
Really? Nah, no way. return output. Oh. Output array. Is this even right?
Yeah, bro.
Dang. That was light.
I have enough code starting. Hell yeah.
Was that light?
Hell yeah.
Beats 100%?
So you.
Nah. That's so jokes.
So I'm proud to see a fake.
No way.
This guy's getting good. Get some more questions for him. Advent of code is about to drop.
Yeah, I don't know why I wanted to iterate through nums2 set.
Yeah. I would have let you go down that road a little bit longer. But Advent of code is about to start.
Man.
Oh, started.
I have to eat.
Okay. This is gonna be okay. Advent of code, day 10. Hoof it. Let's go. You all arrive at a lava production facility on a floating island in the sky. As the others begin to search the massive industrial complex, you feel a small nose boop your leg and look down to discover a reindeer wearing a hard hat. The reindeer is holding a book titled Lava Island Hiking Guide. However, when you open the book, you discover that most of it seems to have been scorched by lava. As you're about to ask how you can help, the reindeer brings you a blank topographic map of the surrounding area, your puzzle input, and looks up at you excitedly. Perhaps you can fill in the missing hiking trails. Okay. The topographic map indicates that the height at each position. The topographic map indicates the height at each position using a scale from 0 to 9. Based on the unscorched scraps of the book, you determine that a good hiking trail is as long as possible and has an even, gradual uphill slope. For all practical purposes, this means that a hiking trail is any path that starts at height 0 and ends at 9. And always increases by height of exactly 1 at each step. Okay. Based on that. One sec. Give me like 30 seconds. I'm gonna just lower the volume on one of my burner accounts where I'm watching the stream. Like I hear myself in the background and it's tripping me out. Give me like 30 seconds. Back. A trailhead is any position that starts one or more height. Here, their positions will always have height 0. This trailhead has a score of 2. What's going on here? Okay, they've been spamming graph questions. So let me just like turn this half screen here. Turn this half screen here. Anyone get the question so far?
You want some of this?
No, okay. You need to focus up. Hello World, part 1.
Damn, this guy's so cheap. He's using VS Code. At least use PyCharm Pro.
PyCharm Pro.
I have PyCharm Pro.
Okay, so John, I'm going to reread the question. So we're at a lava production facility in the sky. As the others begin to search the massive industrial complex, you feel a small nose boop your leg and look down to discover a reindeer wearing a hard hat. The reindeer is holding a book titled Lava Island Hiking Guide. However, when you open the book, you discover that most of it seems to have been scorched by lava. As you're about to ask how you can help, the reindeer brings you a blank topographic map of the surrounding area. So you're given a map, essentially. This is the map, and the map is our puzzle input. And you have to help fill in the missing hiking trails. The topographic map indicates that height at each position using a scale from 0. So we're given a map of like zeros, numbers between 0 and 9. 0 are very low points and 9 is like high points. Based on the unscorched scraps of the book, you determine that a good hiking trail is as long as possible and has an even, gradual uphill slope. For all practical purposes, this means that a hiking trail is any path that starts at 0 and ends at 9, and always increases by a height of exactly 1 at each step. So something like, so they're saying like a hiking trail is something that is like slowly increasing. 1, 2, 3, 4, 5, all the way to 9, right? So hiking always increased by a height of exactly 1. Hiking trails never include diagonal steps, only up, down, left, and right. Okay. From the perspective of the map. So in that square example, it's spiraling 1, 2, 3, 4, 5, 6, 7, 6, 3. I don't even know what the answer to this example is. I guess 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So but it could also be like 1, 2, 3. We'll also look at some of like the other ones as well.
Oh, it's spiraling. Look. So like, hey, check this out. So this is the start. It goes this way, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then it gets to the top.
Yeah, there might be like multiple answers.
There is definitely multiple answers because you could also go this way, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9.
So I'm not looking at that one yet. So you look at the map and notice the reindeer has helpfully begun to construct a small pile of pencils, markers, rulers, compasses, stickers. So a trailhead is any position that starts one or more hiking trails. A trailhead is any position that starts one or more hiking trails. Here, these positions will always have height 0. Assembling more fragments of the pages established that a trailhead score is the number of 9 height positions reachable from that trail via hiking trail. So the number of times we can get to 9, the score of 1. So in the above example, the single trailhead in the top left corner has a score of 1 because it can reach a single 9. So you could reach a single 9, but you can have reached there in different ways, right? This one, using one trailhead, you can get to 2 9s. Okay, so I'm starting to think it's like some sort of like depth first search algorithm where you like you try to like navigate your way to a 9, and if you like can't, then you like, or it's kind of like a backtracking algorithm, or I guess depth first search through here, and you're searching for how many 9s that you can reach, but the depth first search algorithm is very restricted, that like you could only like traverse to the next node if it's one larger than you. So this trail has, because every 9 is reachable via hiking trail. So if you have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 9. How do you get to 9?
You can't get to that 9.
Here?
Yeah, you can only get to like
7, 8, 9.
1, that 9, that 2 9s, 3 9s.
What do they have this 9 here? Doesn't make sense.
No, it's just there to trip you out.
So wait, this trailhead is because every 9 is reachable via hiking trail except one immediately. Okay, one immediately left. So yeah, they are just trying to trip us out. So here, this topograph changed. The trailhead at the top has a score of 1, while the trailhead at the bottom has a score of 2. This larger example has 9 trailheads. Considering it. So what we need to do is when we find a 0, what we need to do is pretty much perform like a backtracking algorithm starting at that 0 and try to get to a 9. And if we get to a 9, we store that in some sort of like results array. And then we pretty much do that for every single 0, like do a backtracking algorithm. Yeah. I think that will solve it. So let's just write like the backtracking algorithm first. So the backtracking algorithm, John, this is a bit more advanced concept, like the backtracking algorithm. It's a bit more of like a brute force kind of thing, but let's go. Let me diagram it for y'all actually. So I definitely didn't think of backtracking part. I first thought, yeah, the thing is, if we use a regular DFS. Because we want to be able to, when we're doing a backtracking, we want to be able to visit the same node twice. So if we just use a regular BFS in like a scene array, it won't let us do that. So we need to like try exploring one path. If it doesn't work, we like reverse going through that path because we want to make those nodes available again for us. We want to make those nodes available for us again. Pretty much like, yeah. That's essentially it. Yeah, because we want to make those nodes available for us. How do I say it? Like in other paths that we're exploring. So let's do a backtrack. Yeah. Oh, dude, you have like GitHub Copilot. How did I turn that off?
I don't even know. Use PyCharm community.
I do not want GitHub.
You have to use PyCharm community.
No, I can take Copilot.
You can use Jupyter. You can use Jupyter.
I can disable Copilot. That would be cheating.
I'm on the what's it called too? I'm on the
dude. Okay, wait. I need to
bottom right. It says bottom right.
Copilot status. I actually don't even use Copilot.
Do you want to use Jupyter Notebook?
No, not really. Dude, I disabled it. Oh, disable completions? Okay, you're right.
Oh, there you go.
Where?
Click it again. Click the face. Disable
completions. Okay, click. Nice.
Oh, man.
Now, my brother is not, he's going to be writing code later and everything's not going to be completing. He's going to be tripping out.
I use PyCharm Pro mostly though.
So what I'm going to do is let's just use like let's just do a snipping tool. Right. And then let's just like explore what this backtracking algorithm is going to do. So throw it on Excalijaw. Sorry, where is this? So we're gonna go in Excalijaw. So basically, every time we hit a 0, what we're gonna do is we're gonna explore 0 or 0, 1, 2, 3, 4, 5, 6. Then we're stuck. What we're gonna want to do is like reverse course, and then maybe try 6 here. Then 7, 8, 9. Now we store that result right here. Then we backtrack. We go 8, 9. Right. Then we store this result. Then we backtrack 7, 6, 5. I don't know where we are, but it's hard to kind of visualize it. But every time we do a 0, we're gonna try to explore 5, 6, 7, 8, 9. Then we'll backtrack. Then we'll store that 5, 6, 4, 4. If there's a 5 somewhere here, we'd also try that path because we still want to like see how that all works. So what we're going to do is we're going to start backtracking at a specific index. So we're going to be given a grid and we're going to be given a row and a column. And then we're going to be given, that's going to be our row and column. And we're going to be given, are you storing the count of 9s reached by the pass and sorting to 0 where you start the back? Not like we just need to count up the unique 9s. So our result is just going to be like a set. Our result is just going to be like a set of like row column pairs. Right? Because like if I get a 9, for example, I could get 9 here multiple times, but we only need to count it. We only need to count it once or twice. Caesar in the building. Get it. So I think the topic contains 2 trailheads, and the trailhead at the top has a score of 1, while the trailhead at the bottom has a score of 2. Wait, what? Okay. The topographic map contains 2 houses. Our top has this. Wait. E. Basically, the trailhead has a score of 4 because every 9 is reachable. We just need to count up the unique 9s that are reachable. It doesn't matter like what 0 started that. I'm pretty sure. What else? Yeah. This larger example is 9 trail. Consider the trailheads in reading order. They have scores of 0. Or what is the sum of all scores of all trailheads? What is the sum of the scores? So this larger example has 9 trailheads. Interesting. Consider the trailheads in reading order. They have scores 5, 6. Oh, okay. Adding these scores, isn't the trailhead 0 and the score is how many 9s it reaches? You're right.
What about you find every 9, you enumerate it to have like its x and y coordinate. You use the x and y coordinate to identify 8s around that 9. If there's no 8 around that 9, you eliminate it from the array. You pop it out.
Wait, say it again.
So like what you could do is so for example here, right? This easy, like this first one, right? What you would do is you could find the 9, enumerate it with the x and y coordinate. Use that x and y coordinate to find.
This guy's spamming.
I was spamming coordinate.
You spam enumerate.
But like you could use those coordinates to find like 8s around it. If this specific 9 doesn't have any 8s around it, you could pop it out of the array.
Yeah, I'm not sure.
No?
This has to you can't use enumerate because this is like we're working with a graph question now.
Okay.
So when you're working with graphs, you can't just use like enumerate is for like linear data structures like arrays. But now we're working with a graph. It's a graph question. We have to use like DFS, BFS, or like backtracking. And you're not familiar with non-linear data structures yet, like graphs and stuff. So let's get it. I think we can probably get this one. But you're actually right. This larger has 9 trailheads. Consider the trailheads in reading order. They have. So basically, what we need to do is find trailheads and get their score. Then we like add up score of each trailhead. So let's say this one. Let's work through this example one last time, and then we'll go implement it. Actually, so this is a trailhead. So any 0 is a candidate trailhead. It's not really a trailhead yet, but pretty much we just want to see how, dude, if LeetCodeHard already solved this, that is crazy. But essentially, what I'm saying is like for each 0 is going to be a candidate trailhead. And then if we get to the candidate trailhead, we just want to check the score of that trailhead. It might be 0, it might be 1, it might be 2. But then once we like do a backtracking algorithm to find like the amount of 9s, we calculate a score for that one. And then we just like have a running result. And then we just add that like the score to the running result. And that's how we'll do this. They have scores of 5, 6, adding these scores together. And then we just return this result. And we pretty much do that for every single candidate trailhead. So essentially what we're going to do first is let's just parse out this graph real quick. So this should return us a trailhead. This should return us a trailhead of score 2. So let's do input. LeetCodeHard, have you solved it already? You done? Let's see. So we split by that.
Oh my god, bro. For real?
How much time?
Yo.
This guy's nuts.
My god.
This guy.
He literally does it and then comes on the stream to see you struggle, bro. Holy.
Okay. This guy is definitely that word. I don't know if that's family friendly.
Cracked?
No, I'm just kidding. I
People
don't
say
even know.
that on Fortnite a lot.
People say that in Silicon Valley. Dude, what the? Okay. Print. Okay, day 10 part 1. Actually, we're going to part 1. Okay. I think I'll be able to sleep early today. Yeah, John. Caesar said that's a valley term.
What's a valley term?
Like, if they use that in Silicon Valley. Dude. Okay, GitHub Copilot is tweaking. Why do you have that?
Why do I have that? Because I don't know how to code, bro. That's the only way.
Yo, John Prout at CFA just did a lead code question in like 5 minutes earlier.
Chill.
Okay. Then we're gonna get the grid. And we're gonna say for lm in input string, we're gonna say, or for row in input string, we're gonna say for Kara.
Trying to make that little Pokemon proud, man. That's why I work so hard. Feed that little.
So for row in input, for Kara in.
Dude, I skipped the gym to code, to learn how to code. Isn't that
This guy's watching podcasts on pandas data frames.
Leave me alone.
For a row in grid, print row.
100 on his way to take all our jobs. Stop, bro. I'm in finance. You're taking my
You're
job.
gonna be a quant, right?
Literally, you're taking my job.
Let's say
Y'all gonna automate finance like tomorrow night.
we're gonna say for a row in range, the length of the grid. For a column in range, the length of the grid 0. So we're looping through all the different rows and columns. We're gonna store a final result and we'll just print that. So what we'll do is for row in range length of grid, for column in this grid, what we're gonna do is if the grid row column is equal to 0. Let me actually just convert these. I want to convert these to a for Kara. If Kara is digit, else. I'll do if it's a digit. I just want to turn it into a. I just want to parse it right away. So row column, if it's equal to 0, just doing quick testing. So it should, okay, captured 0 and 3, and you could see all of these are integers. So yeah, row column 0, and it's row 0 and column 3. So now we need to define our backtracking algorithm. Let's do backtrack. And we're gonna backtrack on the grid given a specific row and column. And yeah, we're gonna be given a grid and a row and column. What's the base case? The base case is like pretty much if the grid row and column is actually equal to 9, we'll return 1. And then we're gonna also need to know our path. So the path is gonna store like a set of all the different elements that we visited. And since it's a backtracking algorithm, we're gonna like add to path. Then we're gonna remove from path at some point. And then in the middle, we're gonna call like backtrack with the grid, the path, the row, and the column. And we're gonna store a result here. And then we're pretty much gonna do return result. We'll start result equals 0. Or no, I think this is good. So pretty much we'll say current value equals the grid. And we're gonna loop through neighbors here, essentially. But we're gonna do current value is equals grid, row, and column. So that's the current value that we're at. So if it's 0, the next value we're looking for is 1. So what we're gonna do is like we're gonna look above us. We're gonna look at our neighbors. Essentially, if we're given a 0, we're gonna check above us, to the left of us, to the bottom of us, to the right of us, for like a 1. So we'll just say BFS use a stack, if I recall. BFS use a stack. I'm doing a backtracking algorithm, not a backtracking and like is a bit different than a depth first search, because the depth first search you'll keep like all the nodes you visit it in like one specific, like you in a depth first search you'll visit every node exactly once, but in this one with a backtracking algorithm you might visit a node multiple times. So that's awesome, guy. You got some questions for my brother later?
Oh God,
this guy's always back,
bro. I have to
you said stop using your phone.
I have to look up what a backtracking algorithm is.
Oh, yeah.
I don't know what a backtracking algorithm or a
So Pat,
DFS is.
Backtracking algo is slightly different than DFS. And it's mostly the main difference is just like how many nodes it visits. Like a backtracking algorithm, you might visit the same node multiple times. But maybe you can like cache that or something. Yeah, maybe we can solve this using dynamic programming or something. But let me see.
2200 lead code. What type of question is that? I'm only limited to array questions. Literally. Find all k indices.
It's an easy question.
Array.
Oh yeah, you can get that one later. Look it up on your phone. 2200.
Nah, I'm good. I won't.
He's already cooked today.
I won't look that up on my phone.
So for neighbors, so what we're gonna say, we're gonna look one up and one right for neighbor row, neighbor column. In what we're gonna do is we're gonna loop through all of our neighbors. So say we're gonna have 4 neighbors because we said, yeah, it's pretty much the same thing as recursion. What's the code you use to parse the graph? This is the code I use to parse the graph.
Stop streaming or slam with lead code. Okay.
Crazy, man. Check that out. Try. You should try it out too. I know that you're in tech also. So that's how you parse that. And I know we'll take the current row and column. We'll go like this. So it says that it only cares about, where did it say? It said somewhere it doesn't look at diagonals. It only looks at up, down, left, and right. So in order to look up, we have to take our row in -1. In order to look left, we have to take our column in plus, or look right, we take our column +1. In order to look down, we take our row, go +1. In order to look left, we take our column +1. So that gets us all of our neighbors and rows. That gives us all our neighbor rows and columns. And then we'll just do some bounds checks. If the neighbor row is less than 0, or the neighbor row greater than equal the length of the grid. So these are bounds checks, or neighbor column is less than 0, or neighbor column is greater than equal to the length of the grid. Continue. We don't want to do that. And then also if, now we know that's in bounds, if if the neighbor row and neighbor column is in the current path that we already visited in path, continue. Because if it's in the path, we don't want to work with it. So like if all these hold, and the current val needs to be 1 up. So let's see. If let's see, grid neighbor row neighbor column is not equal to the current value plus 1. If it's not larger than the current value plus 1, we continue. Otherwise, what are we going to do? We're going to add to the path. So say path.add. Then we'll do path.remove. Because path's going to be a set. And we're going to pass in the neighbor row and neighbor column tuple into the path. We'll say result here equals 0. We'll do result plus equals backtrack grid path. We'll see neighbor row, neighbor column, path remove this. And that's the backtracking algorithm, I think. It's pretty boilerplate. Let's just see if it make sure it works. Backtrack.
You don't have to worry about diagonals?
No, specifically you don't. I mean, if we did, we just add a few extra conditions here. But let's pass in our grid. Let's pass in our row, our column. And what are we doing? Row, column. Oh no, we need to build our path. So we're going to say path equals a set with our row and column. Then we pass that path here. And then we get back a score. And then we say result plus equals the score. Let's just print score. We'll do a F string and we'll say row column score is score. Should say 2. Cool. Now, yes.
What? How'd that work?
See, Decode Hard might be messaging me. Not yet.
What a legend.
Who's this? Oh,
man.
Okay. Now that we have our backtracking, I'm pretty sure that backtracking algorithm works. Let's run it on this. This trailhead has a score of 4 because every 9 is reachable via hiking. Well, let's do this. This should return 36. What?
Oh no.
What did I do wrong here? Okay, wait. So it should result. So if the neighbor row is less, okay, let's just do this logic. Considering the trailhead in reading order, they have scores of 5. So this is one trailhead. 0, 1, 2. Let's see why this trailhead has a score of 5. And then let's just like break after our first trailhead. Let's say wait, how did we get the let me print out the trailheads. So we're saying 0 and 2 has a score of 20. Wait, what's going on here? Result. Okay, let me observe my backtracking algorithm. If the grid row column equals 0, we store row and column in our path. Then we backtrack on the grid on that specific row and column. So if it's already 0, so the current value is 0. So, and the result here is 0. If the grid row column equals 9, we return 1. Okay, now we're at the current value, grid row and column. For the neighbor column, we look up 1, we look right 1, we look down, and we look to the left. If the neighbor row is less than 0, or the neighbor row is greater than equal to the length of the grid, or the neighbor column is less than 0, then we continue. If the neighbor row is in the path, we continue. Or maybe we could just do a regular DFS. Like if it reaches the same trailhead, does it count? Or is it, oh, we just have to count the number of trailheads that it can get to. What is some? Let's see, is trailheads unique? 9 height, the single, wait, let me read this again. So I think we might need to count unique ends. So if it gets to if it can get to 9 in multiple different ways, that only counts as a score of 1. So a trailhead. So the single trailhead in the top left corner has a score of 1. Okay, we just need to also capture like the number of results. Let's see. If row column is not in results, else return 0, and then we say results dot add row column. So we only want to count like the 1 9 once only. And now we're gonna have to pass this result like everywhere, or pretty much just here, and then right here. Not in result. Wait, backtrack. We pass in a set. If the row column not in result, argument of type int is not iterable. Wait, when did I pass the int here? Okay, backtrack. Oh shoot.
Do you have to?
No, I like shadowed one of result set. Result set.
Ask them if the
result set.
Font size is good.
Result set. I think it's good. 36. What's the answer? 36. Cool. Looks like we got that working. Let's delete this. Now let's put in the big, super big input. Oh, I really hope this works so I can sleep early today. Nice. How long have you been leak coding? Let's go. Let's go. Let's go.
He's very fast, but not as fast as
Leak Code Hard is faster.
Oh my god.
Leak Code Hard. Do you want to collab in real life? Let me know. Okay, that's 1 gold star. I'm happy it just worked. Let's see. What's this next one? The first half of this puzzle is complete. It provides the... E, how long have you been studying Leak Code for? You can wear a ski mask for the... I've been leak coding since September. Seriously. Are you based in US? I've been leak coding since September. Seriously. Got an internship luckily for the summer. Nice. People think Leak Code Hard is gonna come on with ski mask. People think collabing with Kodak Black. You see his Breakfast Club? Kodak Black's in Breakfast Club.
Wait, what was he saying?
No, I was just saying he can wear a ski mask for our interview. or collab in real life. He's gonna get here on like the 20th or something.
Is he shy? What?
Dude, we're gonna need him for like day 21, 22, 23.
Oh man.
So you started leak coding since September. So you're actually pretty good then for only 4 months.
Since
Like,
September?
how many questions have you solved? So the ranger spends a few minutes reviewing your hiking trail before realizing something different, disappearing for a few minutes and finally returning with yet another slightly charred piece of paper. The paper describes a second way to measure a trailhead, calling its rating. A trailhead rating is the number of distinct hiking trails which begin at a trailhead. For example, the above has a single trailhead, its rating is 3, because there's actually 3 distinct hiking trails which begin at that position. Okay. So that's what I was doing initially. So then the answer should be 81. Dude,
Dang.
that's what I was doing originally. Let's just
Control Z all the way.
woo! We're done. We got today.
Oh
now I need to run it back for one of my other
I
ones.
did the exact same thing, part 2 for part 1.
Yeah, I was.
How'd you do it so fast though? I'm so confused.
Okay, let's see how we ranked. Let's see how we ranked. Dude. Okay, that was easier than the other day. I'm gonna run back question 9. How did we rank? Bro, I got cooked today. Dude, we got cooked. Damn, why'd they make it so easy today? Alright, get my brother a leak code question. Someone give my brother a leak code question. He wants to show off his skills. And then I'll think of 9. I did 70-ish, but I did a lot of grab questions, recursion, backtracking. Nice. I actually like spam a lot of those graph ones, so my weak point is actually arrays for some reason. Merge sorted arrays. Okay, John, show off your skills.
Merge sorted arrays? Are you kidding me? What does that even mean?
Hey, don't look at the code.
That was C++ though.
No, it's Python 3.
Do not return anything. Modify nums in place.
Oh, we did this already. Give it that's a good.
There's a good one where you gotta think a bit.
I did this live on. Did this live the other day. It's actually hard if you did it in O.
I kind of remember this.
Yeah, this one's hard if you do in O of 1 space. This one's.
Wait, hold on. I have to talk to somebody.
Okay. He's gonna solve a leak code question. We just have to find him a good one. Dude. And I need to solve these questions at some point. I'm gonna upload my response here. Valid palindrome? Okay, that's a good one. That's a good one for a beginner. Valid palindrome. And then if we want, these ones are so funny. Valid palindrome, and then there's valid palindrome 2 and valid palindrome 3. I don't know how to solve valid palindrome 3 efficiently. I was looking at this like yesterday. But I think to solve valid palindrome 1, let me delete all my thing. I'll upload my code right now. I'm gonna upload it to GitHub. Give me a sec. While my brother, he's talking to a girl that he's been talking to for a while. But I'm gonna get him to get off the phone, and this leak code stuff is a little bit more important than that. GitHub.com. Okay, I'm gonna upload my code. Give me a sec. Hey, Liam is in the building. Okay, I'm gonna upload my I'm gonna upload my code here. So for part 1, where are we? Liam, we already solved the question, so it's no longer any fun. But what we're gonna do is get John Peralta CFA to try a lead code. He's actually getting pretty good. He did a lead code question like 5 minutes earlier. So I'm just gonna quickly upload this code. Well, let's see. Somebody give me where's Google guy? Someone give me a good lead code question. Something different. I'll put my brother through this one. Who got some good ones? Let's see. Yeah, and I'll upload my code. Give me a sec. GitHub. Your profile. Your gist. So I'm gonna use this gist thing. Oops. Actually, accidentally showed some PII on the stream. Valid allogram. LRU cache. Okay. Valid allogram. LRU cache. That's classic one. Dude, why does it store all the submissions? KE, I'll get you the stuff after stream. I don't want to accidentally show PII. John, you ready for a valid palindrome?
No, I have to talk to somebody right now. I literally can't. God damn.
FizzBuzz?
These are all light though. Give me a real one tomorrow. I'll be available tomorrow.
Drop in repo. Drop in repo link if you have it.
Oh man.
All right, how long has this stream been? We might just call it a night. Today was an easy day. What's the current time? Well, I'll let everyone get to sleep early. It's already been an hour, so. John Peralta CFA is out of business today. But I'll see y'all in the next stream. We're gonna do day 11 tomorrow. Let y'all get off early. No problem. All right, see y'all in the next stream. This was a quick one. Peace.